Welcome to our review on calorimetry. Now, calorimetry then is quite simply the method that we use to measure the amount of energy that's transferred during a chemical reaction. Now, the way they're going to phrase this in your C3 exam is by talking about different fuel possibilities. So what they're going to be expecting you to do is recall a specific experiment that hopefully you've carried out in class, where you use a spirit burner and that contains different fuels, which will then allow you to record a change in temperature, and we can use that information to then calculate the amount of energy that's transferred by a particular fuel. So what we've got on this slide then is just taking us through how we'd actually carry out a calorimetry experiment. Now, this is one of those topics that could come up as a 6-mark question for you. And what they'd be asking you there is how you could actually compare two different fuels and decide which is the best one to use. Now, what they'd be hoping you're going to write down in that kind of question, first of all, is an outline method of how to carry it out, which is what we see here in the orange box. And I'm going to talk you through that in a moment. And in addition to that, they'd be looking for how you're going to make this experiment a fair test. So when we're talking about a fair test, quite simply what we mean is how we're going to control all of those variables except for the one that we are measuring and the one that we've chosen to change. So if we look through our method then, the first thing we actually need to do is measure a certain volume of water and add that to our calorimeter. Then we've got to record our temperature for the start and the mass of our spirit burner. Now the spirit burner is just that little glass item that holds the liquid fuel. Once we've got that, we place our spirit burner under the calorimeter and we're going to light that and leave that burning for a fixed period of time, say 2 minutes. At the end of that 2 minutes, you extinguish the spirit burner, you record the end temperature of the water, and then we reweigh those spirit burner to find out how much mass we've actually lost. This is one of the calculations we can carry out using the results of a calorimetry experiment. Now, you don't have to memorize this equation because this is one of the ones that's printed on page 2 of your exam booklet. So just inside the front cover, in that big list of equations, you'll find your energy transfer equation. So just to talk you through what we actually need to do then, if you're asked to calculate how much energy is transferred in an experiment, then what we're going to do is the mass of our water being heated in grams times by 4.2 times by the temperature change. Now, the thing to remember here is that the temperature change is the difference between your starting temperature and the end temperature. Don't get caught out just by putting down the final temperature it reaches. Make sure that you work out the difference between your start temperature and your end temperature. So I've given you an example here of the kind of thing that you might be asked. And the question there is, what is the energy transferred to heat 100 grams of water by 20 degrees C? So all we do is we put those numbers into our calculation, which we find on page 2. And the answer there would be 100 times by 4.2 times by 20. And that gives us our answer of 8,400 joules.